Good morning, children. Today we will be studying about rate constant and the characteristics of rate constant. It is being observed that during a particular reaction, the concentrations of the reactants decreases and those of the products increases with the passage of time. And it is also being observed that the rate of a reaction decreases with the decrease in the concentrations of the reactants. Let us take an example to explain this. Take a test tube. In this test tube, you take sodium bicarbonate in the solid form, powdered form, and to this you add dilute hydrochloric acid. During the reaction, carbon dioxide gas is being evolved, and the rate of the reaction, this particular reaction, can be measured with the rate of evolution of CO2 gas. So in the beginning what happens? The rate of the formation of bubbles of CO2. The rate of formation of bubbles of CO2 is fast. And with the passage of time, the evolution of CO2 gas decreases. And as we know that during the reaction, the concentrations of sodium bicarbonate and of dilute hydrochloric acid decreases, the rate of evolution of CO2 gas also decreases. It means that the reaction rate decreases. Is it clear to you with this example that the rate of a reaction decreases with the passage of time since the concentrations of the reactants decrease. Now, this quantitative relationship between the reaction rate and the concentrations, molar concentrations of the reactants is being explained by law of mass action, which was given by M. Goldberg and P. Weiss. According to the law of mass action, at a given temperature, the rate of a reaction is directly proportional to the product of the molar concentrations of the reactants, with each concentration term is raised to a power equals to its stoichiometric coefficient as appeared in a balanced chemical equation. The same one. Let us take an hypothetical equation and the law of mass action will be more clear here. Look at that board. Let us consider an hypothetical equation, reaction equation A plus B gives products. So, according to law of mass action, reaction rate, what it was at a particular temperature, the reaction rate is directly proportional to the product of the molar concentrations of the reactants. So it is your molar concentration of A into molar concentration of B, with each molar concentration term is raised to a power what? Equals to its stoichiometric coefficient as appeared in the balanced reaction equation. I hope it is clear. At a given temperature, the reaction rate or rate of a reaction is directly proportional to the product of molar concentrations of the reactants, with each concentration term is raised to a power equal to its stoichiometric coefficient as appeared in the balanced chemical equation. So now we can write that is your reaction rate is equal to proportionality constant K into molar concentration of A to the power A into molar concentration of B to the power B, where K is proportionality constant called rate constant. Now let us consider, let the molar concentration of A is equal to 1 mole per liter and molar concentration of B is equal to 1 mole per liter. Then reaction rate will be equals to K into 1 to the power A into 1 to the power B, that equals to what? K into 1 into 1, that equals to K. That is your reaction rate is equal to K. Now in this way we can define the rate constant. In this way, rate constant of a reaction is defined as the reaction rate of the reaction when the molar concentrations of each of the reactants is 1 mole per liter. So this is the definition of rate constant. I hope it is clear. Now coming to, so if the definition of rate constant is being asked during the exam, you can write this expression, make it equals to, when the condition is there, when the molar concentrations of the reactants is your 1 mole per liter, then reaction rate will become equals to what? K. And based on that you can define it. Now coming to characteristics of rate constant. At number 1, there are altogether 5 characteristics. Number 1 is, at a given temperature, the value of K is constant and is the characteristic of the reaction, and K is directly proportional to temperature. What does it mean? For a particular reaction, if the temperature increases, the value of rate constant will also increase, and if the temperature decreases, the value of rate constant will also decrease. The second one is, different reactions have different values of K. Third one is, the value of rate constant gives an idea about the reaction or reaction rate. We can write it reaction rate. That is, greater is the value of K, faster is the reaction, and vice versa. It means that lesser is the value of K, slower is the reaction. So we can say that K is a measure of rate of a reaction, that is your rate constant is a measure of rate of a reaction. Fourth one is the value of K does not depend upon the concentrations of the reactants. It is independent of the concentrations of the reactants. And fifth one is the units of rate constant depend upon the order of the reaction. This order of the reaction we will be studying in the coming class. Okay, thank you.